NEC 250.32 states that where buildings or portions thereof are supplied by a common electrical system, a main disconnecting means shall be provided. The key question is whether the retail shops and the anchor store constitute separate buildings or portions thereof according to the NEC. The definition of building in NEC Article 100 states a building is a structure that stands alone or that is separated from other structures by fire walls with only openings protected by approved fire doors. In this specific situation, the retail shops are physically attached to the anchor store, and importantly, they are not separated by fire walls. Therefore, according to the NEC definition, they cannot be considered separate buildings. Now let's address the requirements for disconnects in the retail shops. NEC 230.70 generally requires a disconnecting means for each branch circuit that supplies an appliance or other equipment. However, there is an exception. This requirement does not apply to branch circuits that supply lighting or other general purpose loads. In the scenario described, the branch circuits originating from the house panel and extending to the retail shops are primarily supplying general purpose loads such as lighting and convenience outlets. Therefore, a disconnecting means is not typically required within each of the individual retail shops themselves for these types of circuits. The fact that the parking lot lighting is connected to the same house panel does not fundamentally alter the determination of whether the retail shops and anchor store should be treated as separate buildings from an electrical code perspective. The parking lot lighting system is considered distinct from the electrical system serving the buildings themselves. In summary, based on the provided information and the relevant sections of the NEC, it appears that the initial interpretation requiring each retail shop to be treated as a separate building may not be entirely accurate. Given that the retail shops are attached to the anchor store without fire walls, they are likely considered part of the same building for electrical code purposes. Consequently, a disconnect may not be strictly required within each retail shop, especially if the branch circuits are primarily serving general purpose loads like lighting and receptacles. It is acknowledged that there may be a significant number of existing strip malls or retail centers that may not fully comply with this specific interpretation of the NEC. However, this observation does not diminish the importance of adhering to the NEC requirements. It remains the responsibility of the design engineer, electrical contractor, and plan reviewer to ensure that all electrical designs and installations are in compliance with the NEC and all applicable local amendments. When evaluating electrical installations in similar retail settings, firstly, carefully review the architectural plans to determine if the retail spaces are separated by fire walls as defined by the NEC. If fire walls exist, the spaces may be considered separate buildings requiring individual service disconnects and grounding electrodes as per NEC 250.32. Secondly, examine the electrical design to ascertain the types of loads being served by the branch circuits originating from the house panel. If the majority of the loads are general purpose, such as lighting and receptacles, individual disconnects within each retail space may not be necessary. Thirdly, verify compliance with local amendments to the NEC. Local jurisdictions often have specific requirements or interpretations that may differ from the national code. It's essential to be aware of and adhere to these local rules. Fourthly, ensure proper grounding and bonding of all electrical equipment in accordance with NEC Article 250. This is critical for safety and to minimize the risk of electrical shock or fire. Fifthly, consider the voltage drop in branch circuits, especially over long distances. Excessive voltage drop can negatively impact the performance of electrical equipment and may require upsizing conductors to compensate. Sixthly, provide adequate overcurrent protection for all branch circuits in accordance with NEC Article 240. This protects the wiring and equipment from damage due to overloads or short circuits. Seventhly, use appropriate wiring methods for the specific application and environment complying with NEC Chapter 3. This includes selecting the correct type of conduit, cable, and wiring installation. Eighthly, ensure that all electrical equipment is properly listed and labeled by a recognized testing laboratory such as UL or ETL. This indicates that the equipment has been evaluated for safety and performance. Ninthly, conduct thorough inspections of the electrical installation during and after construction to verify compliance with the NEC and approved plans. Tenthly, maintain accurate and up-to-date electrical drawings and documentation for future reference and maintenance. These documents should include circuit schedules, panel layouts, and wiring diagrams. Furthermore, consider the specific requirements for emergency lighting and exit signs in retail spaces, as these are critical for life safety. Emergency lighting must be powered by a separate emergency power source or have battery backup to ensure illumination during a power outage. Exit signs must be clearly visible and properly illuminated to guide occupants safely out of the building in an emergency. When designing and installing electrical systems for retail centers, it's crucial to coordinate closely with the architect, mechanical engineer, and other trades to ensure that all systems are integrated properly and comply with all applicable codes and standards. This includes coordinating the location of electrical panels, conduit runs, and equipment to avoid conflicts with other building systems. Additionally, consider the potential for future expansion or changes in the retail spaces. Design the electrical system with sufficient capacity and flexibility to accommodate future needs such as additional lighting, equipment, or outlets. This may involve installing spare conduits, increasing panel board capacity, or providing additional raceways. Regular maintenance and testing of the electrical system are essential to ensure its continued safe and reliable operation. This includes inspecting electrical panels for loose connections, corrosion, or damage, testing ground fault circuit interrupters, or GFCIs, and arc fault circuit interrupters, or RFCIs, to verify their functionality, and performing insulation resistance testing on conductors to identify potential insulation breakdown. Also, consider the energy efficiency of the electrical system when selecting equipment and designing the layout. Use energy-efficient lighting fixtures, such as LED lamps, and install occupancy sensors to turn off lights in unoccupied areas. This can significantly reduce energy consumption and lower operating costs. When dealing with electrical plan reviews and inspections, it's important to communicate clearly and professionally with the plan reviewer and inspector. Provide them with all the necessary information and documentation to demonstrate compliance with the NEC and local codes. Be prepared to answer their questions and address any concerns they may have. If you disagree with their interpretation of the code, respectfully explain your reasoning and provide supporting documentation. Ultimately, the goal is to work together to ensure that the electrical installation is safe, compliant, and meets the needs of the building occupants. In addition to the above considerations, remember that the NEC is a living document that is updated every 3 years. It's essential to stay current with the latest edition of the NEC and any applicable local amendments. This can be achieved by attending industry training courses, subscribing to relevant publications, and participating in professional organizations. By staying informed and following best practices, you can ensure that your electrical designs and installations are safe, reliable, and compliant with all applicable codes and standards. Now, let us also consider some examples in our explanation. Firstly, a single retail space within a strip mall is leased to a clothing store. The store's electrical needs include general lighting, display lighting, cash registers, and HVAC equipment. All of these loads are supplied by branch circuits originating from a common house panel located in the building's electrical room. In this scenario, because the retail space is not separated from the adjacent spaces by firewalls, it is generally considered part of the same building for electrical code purposes. Therefore, a separate service disconnect is not required within the clothing store. However, the branch circuit supplying the store's electrical loads must be properly protected by overcurrent devices in the house panel, and the store must have adequate lighting and receptacles to meet its operational needs. Secondly, a large anchor store, such as a supermarket or department store, is located at one end of a strip mall. The anchor store has its own dedicated electrical service and panel boards, separate from the house panel that serves the other retail spaces in the strip mall. In this case, the anchor store is considered a separate building or portion thereof, and it must comply with all applicable NEC requirements for a separate electrical service. This includes providing a service disconnect, grounding electrode system, and overcurrent protection for all branch circuits. Thirdly, a parking lot lighting system is installed to illuminate the parking area surrounding a strip mall. The parking lot lights are powered by branch circuits originating from the house panel that also serves the retail spaces in the strip mall. In this situation, the parking lot lighting system is considered a separate electrical system from the building's electrical system. Therefore, the NEC requirements for grounding and bonding the parking lot lighting system are different from those for the building's electrical system. The parking lot lights must be grounded and bonded in accordance with NEC Article 250. However, the fact that the parking lot lighting is powered from the same house panel does not necessarily mean that the retail spaces in the strip mall are considered separate buildings. Furthermore, let's also consider what happens during a renovation project. For example, a retail space in a strip mall is being renovated to accommodate a new tenant. The renovation includes adding new lighting fixtures, receptacles, and HVAC equipment. During the renovation, the electrical system must be modified to accommodate the new loads. The electrical contractor must ensure that the modifications comply with the NEC and all applicable local codes. This includes providing adequate overcurrent protection for the new branch circuits, using appropriate wiring methods, and properly grounding and bonding all electrical equipment. Secondly, a strip mall is undergoing a major remodel, which includes adding firewalls between the retail spaces. After the remodel, each retail space will be separated from the adjacent spaces by firewalls that meet the NEC definition of a fire-rated barrier. In this case, each retail space may be considered a separate building or portion thereof, and each space may be required to have its own service disconnect and grounding electrode system. The electrical contractor must carefully evaluate the new construction and determine whether the firewalls meet the NEC requirements for separating buildings. The electrical system must be designed and installed accordingly. Thirdly, a new technology installation may cause changes. Imagine a strip mall is upgrading its lighting system to LED technology. The new LED lighting fixtures are more energy efficient and have a longer lifespan than the old fluorescent fixtures. During the upgrade, the electrical contractor must ensure that the new LED fixtures are compatible with the existing wiring and electrical system. The contractor must also verify that the new fixtures comply with all applicable energy efficiency standards and codes. The upgrade may also require replacing the existing ballasts with LED drivers. In addition to the above scenarios, it's important to consider the specific requirements for electrical safety in retail spaces. Retail spaces often have a high volume of foot traffic, and customers may come into contact with electrical equipment. Therefore, it's essential to take precautions to minimize the risk of electrical shock or fire. This includes using ground fault circuit interrupters, or GFCIs, in areas where there is a risk of water exposure, such as restrooms and break rooms, providing adequate lighting to prevent tripping hazards, and ensuring that all electrical equipment is properly maintained and inspected. Also, retail spaces often have a variety of electrical equipment, such as cash registers, computers, and point-of-sale systems. It's important to provide adequate power and surge protection for this equipment to prevent data loss or damage due to power surges or outages. This may involve installing dedicated circuits, surge protectors, and uninterruptible power supplies or UPSs. Proper planning, design, and installation are essential to ensure the safety and reliability of the electrical system in a retail center or strip mall. By following the NEC and all applicable local codes, you can create a safe and efficient electrical environment for both employees and customers. The authority having jurisdiction, or OJ, is the organization, office, or individual responsible for enforcing the requirements of a code or standard, or for approving equipment, materials, and installation, or procedure. The AHJ can vary depending on the location and type of project. In some cases, the AHJ may be a local building department or electrical inspector. In other cases, it may be a state or federal agency. It is important to identify the AHJ for your project and to work closely with them to ensure that your electrical installation complies with all applicable codes and standards. The AHJ has the authority to interpret the code and to make decisions about whether an installation is compliant. Their interpretation may differ from your own, so it is important to be respectful and to listen to their concerns. If you disagree with the AHJ interpretation, you can appeal their decision. However, it is important to have a strong understanding of the code and to be able to support your position with documentation and evidence. Working with the AHJ can be a challenging process, but it is essential to ensure that your electrical installation is safe and compliant. By communicating effectively and being respectful of their authority, you can build a positive relationship with the AHJ and ensure that your project is successful. In addition to complying with the NEC and local codes, it's also important to follow industry best practices for electrical design and installation. This includes using high-quality materials, following proper wiring methods, and conducting thorough testing and inspection. Industry best practices can help you to avoid common electrical problems and to ensure the long-term reliability of your electrical system. There are many resources available to help you learn about industry best practices, such as trade associations, technical publications, and online forums. By staying informed and following best practices, you can improve the quality of your electrical work and enhance your reputation as a skilled and knowledgeable professional. When working on electrical projects, it's essential to prioritize safety at all times. Electrical work can be dangerous, and even a small mistake can have serious consequences. Therefore, it's important to follow all safety precautions and to use appropriate personal protective equipment, or PPE. This includes wearing safety glasses, gloves, and appropriate clothing. It's also important to energize electrical circuits before working on them and to use lockout/tagout procedures to prevent accidental energization. Finally, it's important to be aware of the potential hazards associated with working around electricity and to take steps to mitigate those hazards. This includes avoiding contact with water, keeping a safe distance from overhead power lines, and using insulated tools. By following safety precautions and being aware of the potential hazards, you can minimize the risk of electrical accidents and ensure that you and your co-workers stay safe on the job. Finally, consider the impact of new technologies on the electrical industry. New technologies, such as smart meters, electric vehicles, and renewable energy sources, are changing the way we generate, distribute, and use electricity. These technologies present both challenges and opportunities for electrical professionals. To stay competitive in the industry, it's important to embrace new technologies and to develop the skills and knowledge necessary to work with them. This may involve taking additional training courses, attending industry conferences, or seeking certifications in specific areas. By staying ahead of the curve and embracing new technologies, you can position yourself for success in the evolving electrical industry. Also consider the following scenario. A strip mall owner decides to install electric vehicle charging stations in a parking lot. The charging stations will be used by customers and employees who drive electric vehicles. The electrical contractor must design and install the charging stations in accordance with NEC Article 625, which covers the requirements for electric vehicle supply equipment, or EVs. The contractor must also consider the impact of the charging stations on the existing electrical system and ensure that the system has enough capacity to handle the additional load. The charging stations must be properly grounded and protected by overcurrent devices. The contractor must also coordinate with the local utility company to ensure that the charging stations are connected to the grid properly. Also consider a small change to an appliance. A retail space in a strip mall decides to replace its old air conditioning unit with a new, more energy-efficient model. The electrical contractor must disconnect the old unit and connect the new unit to the electrical system. The contractor must ensure that the new unit is properly grounded and protected by overcurrent devices. The contractor must also verify that the new unit complies with all applicable energy efficiency standards and codes.